Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about a recent discovery of a ring that has been developing around the dwarf planet which is known by the name of Quaoar. So we are going to discuss in this detailed video that why the discovery of this ring around this dwarf planet is very much interesting for the scientists, and also we are going to discuss in detail that how any celestial body is characterized as a dwarf planet and what exactly is the term Roche limit, which is a mysterious term that has come with regards to this recent discovery of the ring. So first of all, to give you the brief introduction of this particular topic, recently the astronomers have found a ring around the dwarf planet which is situated somewhere at the edge of our solar system, and the name of this planet is Quaoar. So the ring, however, is positioned very far away from the planet than usually what we find the position of the ring around this planet, and thus due to this finding, it defies several theoretical explanations, several mathematical explanations that tells us that how far a ring should develop from any celestial body. If we talk about the exact research that has been done regarding this particular topic, so the journal that has been published is called as a dense ring of trans-Neptunian objects Quaoar outside its Roche limit, and the study has been done by Bruno Morgado of Federal University of Rio de Janeiro in Brazil, as well as Bruno Siccardi of the Paris Observatory and some other scientists as well. So we know that a lot of planets and dwarf planets do have ring around them. For example, we have a lot of planets within our own solar system. The 8 planets which we have also have rings. So why the finding of this ring is so much surprising? So the first surprising reason is that the ring lies far away from the Roche limit, and the Roche limit refers to that part or that distance from celestial bodies beyond that rings are not supposed to exist. And this is the reason why the scientists are very much puzzled due to the discovery of the ring beyond the Roche limit as far as the Quaoar is concerned. And thus, the implications of this discovery might actually force astronomers, physicists, astrophysicists to rethink the laws that govern the planet readings and the position of the planet readings. So basically, if you take a look from the picture, this is the celestial body, that is a dwarf planet Quaoar, and as we can see, this blue area, the blue horizon represents your Roche limit of this Quaoar, and as you can see, the position of the ring is quite far away, at a quite far distance from the actual Roche limit of this particular planet. So let us first try to understand that what is the Roche limit. So Roche limit was a limit that was given by French astronomer Edouard Roche in year 1848, and he explained this that it is that distance, that minimum distance from a planet or any celestial body where the moon turns into a ring. For example, suppose we have Earth. So we know that Earth has only one natural satellite, that is a moon. And if suppose the distance between moon and Earth reduces to such an extent that at a certain time, at a certain distance, the moon will not be able to remain its original form, but rather it will break down into smaller fragments and then it will convert into a ring that will keep on orbiting around the Earth. This basically happens because of the two forces that are basically acting on the celestial bodies. One force which we call as tidal force, and another force is the gravitational force of the moon itself. So let us try to understand first of all this Roche limit on a map or on a diagram. So first of all, if we can see, suppose this is our planet. For example, we can consider this as our Earth itself, and we have a certain distance where the Earth's moon are situated. So suppose this is the current distance of the moon. And this blue line that you are seeing in this particular diagram, this blue line is a representation of the Roche limit of this particular planet, that is our Earth. So as long as the moon of the Earth, the same logic you can apply for any planet in the moon system. So let us take example of our Earth and moon. So as long as our moon is lying beyond the Roche limit of Earth, it will remain in the spherical shape that the moon has attained. But as the distance between moon and Earth will start to decrease, gradually Earth will start to apply a strong gravitational pull on this particular side of the moon. And due to this strong gravitational pull of the Earth, what will happen? Moon will not be able to remain its spherical shape, rather than start to get stretched out in both directions. And thus, as it reaches more and more near to the Earth's surface, and as it crosses the Roche limit, now at that time what will happen? Moon will not be able to remain in a spherical original form, rather than due to the strong effect of gravitational force of Earth, it will disintegrate into several small sized objects, small rocky objects, we can say. And thus, all these rocky objects will start to revolve around the Earth, around these Roche limit areas at different times, giving a ring kind of shape formation around the planet. So that is why Roche limit is very important, because beyond Roche limit a ring should not exist, rather than the existence of moon should be more probable. But within the Roche limit, moon should not exist, but rather than the probability of development of ring is more higher. And that is where the dilemma lies, that is where the surprise lies, because actually the ring that we have discovered about this particular planet, Quaoar planet, dwarf planet, basically it is lying very far away from the Roche limit. So has such event, as we have discussed, that when moon enters into the Roche limit boundary, it disintegrates into several different celestial objects or several different celestial rocks. So has such events occurred in the past? And the answer is obviously yes. It was year 1992 when we have a comet. The comet is called as Shoemaker-Levy 9. So this comet Shoemaker-Levy 9 got very close to Jupiter, and due to the strong gravitational pull that the Jupiter exerted on this particular comet, and once it breached the Roche limit area, it was broken apart by the gravitational force, which we also call as tidal force. And thus, in year 1994, what happened? One of the rocky objects that has developed due to the disintegration of this particular comet collided finally with the planet, providing us the first direct observation of any extraterrestrial collision of the solar system objects. So that is why we can understand that this actual, what we are talking about, this theoretical understanding of our Roche limit has actually been verified in year 1992 and 1994. So the question comes that, as we know that Quaoar dwarf planet lies very far away from the Earth, it is almost at the outer edge of our solar system. So how the ring has been discovered by the astronomers? So in such cases, the discovery of the ring or the discovery of the important characteristics of the planet or any celestial body is not done directly, but it is done via a process that is called as stellar occultation. A stellar occultation basically allows the astronomers to observe the sharp silhouettes of the planet for a brief period of time. And the particular planet, that is Quaoar, which we are talking about, between 2018 to 2021, almost it has four different stars. It has passed across the four different stars, the background of four different stars, and thus we also have got shadow of the eclipses of this particular planet. Let us first try to understand then what is the stellar occultation. So as you can see from this particular diagram, suppose this is our Earth, from where all the observers, different astronomical observatories are located, and suppose we want to know about a minor body, a small celestial body. In this case, it is a Quaoar dwarf planet. So we cannot directly look at this body because this body is not emitting any light toward us, and thus it is completely in the darkness. But sometimes what happens, some star passes in the background of this minor celestial bodies. And when the star passes in the background of this minor celestial bodies, we know that stars emit light, and thus this star that is emitting light, it also provides us with a silhouette, provides us with the dark shadow of this minor body, and then we can actually see around this minor body, we can actually see the kind of eclipse that is happening due to the passage of a star in the background of this minor body. And by observing in that time, you can understand the structure, we can understand the shape, you can understand if this star has any, if this celestial body has any ring around it or not. So that is the process which is known as stellar occultation. So let us try to understand a few other important points about this particular dwarf planet Quaoar. So as we have discussed, it is a dwarf planet with an estimated radius of almost 555 kilometers, and it is roughly half the size of the Pluto. Pluto earlier was considered as a planet, but later on it also has been classified or reclassified as a dwarf planet. And as far as the location of this particular dwarf planet Quaoar is concerned, it is situated in the outermost edge of solar system, which is also called as Kuiper belt. So the question obviously comes that where is Kuiper belt situated? So as we can see, this is our orbit of Jupiter. Here we have Saturn, here we have Uranus, and we have Neptune, and then you can see the orbit of Pluto. And beyond the Pluto, or between, we can say, Neptune and Pluto, there is a large number of small rocky objects, rocky celestial objects are there that are found across the solar system, the outer edge of solar system, and this belt is what we refer as a Kuiper belt. If we try to compare this particular dwarf planet Quaoar, we can understand that it is roughly half the size of Pluto, and as we can see, it is almost 10 times smaller than our own planet Earth. And if we compare the size, we can see that it is also very smaller from our moon, because moon's radius is almost 2100 miles, while Quaoar's radius is almost 800 miles. So the question comes that how can we classify, or how astronomers across the world classify any celestial object as a planet or dwarf planet? So this classification is done by a body that is called as International Astronomical Union, and as per International Astronomical Union, that is IAU, it has given three criteria to be classified to classify any celestial object as a dwarf planet. The first criteria is it should be orbiting around the sun, that is similar to planets. Second, it must have enough gravity to pull its own mass into a round shape. This is the criteria that is common for both planet as well as dwarf planet. The third criteria, where the planet and dwarf planet differs with each other, is that the planet clear its orbit of all the smaller objects. That means when the planet is orbiting around the sun, no other similar size object or smaller objects are found around its orbit. But that is not the case with dwarf planet, because such similar size objects or smaller objects are almost every time found around the orbit of this particular celestial body. And that is why the celestial body that has not been able to clear its orbit, to clear its surrounding of smaller objects, are then classified as a dwarf planet, and so is Pluto and Quaoar. If we talk about the major dwarf planets that we find in our solar system, so obviously the most important one is the Pluto. Apart from that, we have Eris, Ceres, Haumea, and Makemake. These are the 5 major dwarf planets that we have understood about, that we are interested as humanity, or as a human, we are interested to understand about these. Now, question comes that as we have discussed, there is a Roche limit, and beyond Roche limit, the object should stay in the shape of a moon, and within the Roche limit, it should disintegrate and form a ring-like shape. So why Quaoar has a far out ring? How can we explain this? So scientists have clearly said that there can be a variety of explanation, but we cannot say that this is the proper explanation with 100% certainty. That means as of now, no one is sure that why Quaoar is defying the general principle or general astronomical principle that we have established on our Earth. So first of all, the one reason what can cause far out ring in Quaoar is believed by scientists to be the Quaoar's moon, that is called as Wavewort. And it is believed that Quaoar and Wavewort together might be contributing to the gravity or gravitational force in such a manner that is somehow holding the ring still. The other possibility is that the ring's particles are colliding in such a manner that they are not able to coalesce, that they're not able to come together to form a single spherical object, which we can call as a moon. So the method of collision, the rate of collision, the process of collision might be quite different, or the overall gravitational balance that we are seeing between the Quaoar, its moon Wavewort, and this ring might be very different from what we can understand. So these are the two main reasons how we can understand that why it has a far out ring. But anyway, what we can say in conclusion is no matter whatever is the region, the astronomers believe that this particular study, this new study that we have observed, points to the possibility of discovering more rings around smaller planets like Quaoar in the outer solar system, and which might expand our understanding of the planetary system. So obviously, it is a very important and a scientific breakthrough kind of discovery that we just have observed. So I hope you understood about this entire topic. If you like the video, please hit the like button, share it with your fellow aspirants, and subscribe to our channel for more such content. Thank you very much.